4. Yes, we're doing word problems. No, do not panic. Okay? That means no jaw-dropping faces over there. All right, so basically on page 403, that page is just kind of going over some certain, like, words that you'll see in these word problems and kind of what they mean when you go to draw a picture. So, like, the first one says perpendicular to. In a word problem, if you see, like, say, like, something is, or a light pole is, like, perpendicular to the ground, that means, or, like, this sentence, the branch of the tree is perpendicular to the trunk. So, like, if this is the trunk of the tree, the branch sticks out, perpendicular means it's a right angle, right? So that's going to tell you where the right angle of your triangle should be drawn. All right, and then the height is always going to be an adjacent or opposite side. It's not going to be the hypotenuse. So length or distance traveled, like from the base of a tree, building, whatever. So, like, the turtle walked away from the base of the tree for 10 feet. So, again, it's going to depend on what your reference angle is, but that's typically going to be, like, along the bottom. You just kind of draw it how it says it. So, an angle of 30 degrees. So, the wire made an angle of 30 degrees with the ground. So, if this is the wire, this is the ground, that means this angle down here would be our 30-degree angle. Right, so it's just, and then angle of inclination is always going to be an angle from the bottom, like, up. It's always going to be your bottom angle there. Because it's like how far up from the ground it's rising. Like how much it's inclined. Okay? So, let's... Okay, so let's look at example A that's on page 404 here. All right, so let's read through this problem. So it says the angle of inclination from the bottom step of the Lincoln Memorial to the top of the Washington Monument is 7.5 degrees. So that means I'm going to, like, kind of draw an angle here, right? And it's a little angle. I'm going to label it 7.5 degrees. Right, angle of inclination, so it's always going to start at the bottom, go up. Okay, then we know that the Washington Monument is 555 feet tall. So, again, if this is our bottom step of the Lincoln Memorial, right, Washington Monument would then be where? Yes, it's going to be this part here. Okay? Does that make sense? Does everybody see how we got that? How we drew that? All right, and so we know that that height is 555. So that's that side of the triangle is 555. Then the question's asking us to find the distance between the Lincoln Memorial and the Washington Monument. So we are looking for this distance here. Okay? Right, so again, it's just kind of, so we'll just say that's B and that's the ground. Okay? So, a lot of these, I just want you guys to be able to draw the picture and set it up. I'm not even asking you to solve it. We'll do a couple where we're going to solve, but for the most part, I just want you to be able to read it, draw the picture. Okay? See, that's not so bad. We're drawing pictures. We can do that. Drawing triangles, really. All right, let's do another one. Ew, I don't like that one. Hold on. Okay, let's look at example C that's on page 406. So this one says a summer camp is installing a zip line across the lake. The construction crew knows that the elevation of two opposite meadows, allowing them to determine that the line will drop 27 feet from the tower on the high meadow to the one on the low meadow. Right, and this one already gave you a picture, which is kind of nice. So again, we've got this. There's a higher meadow here and a lower one over here. But again, we're just going to say. And then we have this. So we know that this is 27 feet. Because if this is like the top of the high meadow, this is the top of the low one. The distance from the low tower to the high tower is 397 feet. So that one is going to be up here. Because it's talking about the distance between the towers, not the distance like on the ground. Or like the shortest distance. And then it's asking us to find, to the nearest tenth, what is the angle of inclination from the low tower to the high tower? So what angle are we looking for? What's angle of inclination mean? Yes, the one on the left. Right? And so that we've got a right angle here. So let's solve this one. All right, so this is a right triangle. What two sides do we have with our reference angle? This is the opposite. And this is hypotenuse. What trig function combines those two? Sine. So we can say sine theta is equal to what? So what could we do from here to find theta? So we'll plug this in the calculator using the inverse trig function. So we're going to plug it in so it looks like this. So sine -1 of 27 over 397. So we'll plug that in the calculator and get a number. What'd you get?
3.899. Did I do it wrong?
No, you did. I was looking at the wrong. I was like, that sounds better than what I was looking at the wrong problem. Right, so that means that angle is 3.89 or roughly 4 degrees. It's a very tiny angle. Which kind of makes sense because it's a very awkward triangle. Mine looks a little too disproportionate. But. So basically, these are just like the ones we did at the end of 8.3, where you had parts of the triangle, and you just have to like combine the trig functions. Like make the trig function and then use the calculator to solve it. That's not too bad, is it?
We'll see if I can actually draw the triangle.
Okay.
Is this the kind of stuff that you see on like the SAT? Gross. I'm glad that I learned that now.
Yeah, that's why I've really been pushing to get this Trig chapter done, because this is about the extent of what pops up on the ACT, SAT is just your basic SOHCAHTOA and applying it to like board problems.
I don't remember seeing a lot of this stuff on the PACT, and they can correct me if I'm wrong, but I do remember seeing this kind of stuff on the SAT.
Yeah, the ACT, it just kind of depends. Sometimes it's more trig heavy and other times it's not. But theirs even still is not so much word problem based as it is like, here's a triangle, what's the sine of this angle? Like stuff like that.
The stuff on the PACT that I know I got wrong was all of the graphing stuff. That was really it. Like, and it was the same way on the standardized testing. Like, I couldn't do the graphing stuff, but like I could sort of do like everything else.
Yeah, I was hoping to really get into some more graphic stuff with you guys this year, but having 2.5 weeks remotely kind of, and like where I was forced to do testing review for a whole week, that kind of killed that plan. But okay. I'm gonna let you guys go ahead and time it. We'll finish it up tomorrow, and then once we're finished tomorrow, we'll go ahead and start doing the notes for 8.5 tomorrow, because it won't take very long. So this is page 408. We're gonna do 1 through 10. Now 1 through 8, you are just drawing the pictures. Only 9 and 10 do you have to solve for. Okay. So 1 through 8, you're drawing the triangles, labeling all the parts with the correct numbers and things like that. Okay? Okay, so number 1 says a 20-foot ladder, so that's how long the ladder is, right, is leaning against the roof of a house. So, like, if this is the house, you know what, we'll even draw a house. House, right? We have a ladder leaning up against it. That is how long? 20 feet. Okay.
Yeah, I don't know how to draw the picture.
I made the ladder straight up.
All right. So again, it just says a ladder is leaning up against a house.
Yeah, but
So-
how do you know what way it's leaning up against?
Yeah, is it going like straight up or out or?
All right. If it's leaning, that typically means it's like slanted.
Well, it can like be leaning, but like.
No, that would just be like propped up against. Like when it says leaning, it means it's like this. If it says something is leaning, that's typically going to be your hypotenuse. Okay?
Leaning equals hypotenuse.
Pretty much, yeah.
Okay.
So I drew a house, drew a ladder up against it. And I know the ladder is 20 feet long. And we know that the house is 13 feet tall.
So is that the opposite? Would that be the opposite?
Well, so we know that the house is 13 feet tall. I'm just assuming it means like that. I don't know. Don't judge my house drawing too closely. All right, and then I'm just going to, make it form a triangle.
That's it?
Yeah.
How's that so hard though?
It's not. And so this is...
Can we do number 2 also? And 3, 4, 5.
All right, we're not going to do all of them.
Can we actually do like number 2 and 3 though? Like being serious?
All right, we can do 2, and then you guys are on to row for a little bit.
Okay, I'll
What's
see
in
you
red?
later.
What's in red?
I just labeled it as B. Like, that's the part of the triangle that we're...
6, I was like,
I just labeled the part that we're looking for.
How do we draw a marching band?
You don't draw a marching band, Savannah. Okay, so let's do number 2. Are we ready? Everybody good with number 1 here? Okay. Okay, so a marching band is practicing in the school parking lot. They start out heading north,
so that's the side.
right? I'm just drawing an arrow north, and they walk for 32 yards. Then they turn east.
I'm glad I wasn't the only one.
And then they walk for 18 yards. Look at that, a nice right angle.
And then you just,
Ta-da!
so the hypotenuse would be the one you're looking for?
Well, is that what's it asking? Yeah, how far away? Yes. So, call it X. Call it whatever variable you want. I don't care.
Can we really do number 3? Like, I'm sorry.
I want you to try it on your own
Like,
first.
I don't know what we're supposed
Okay,
to be
so
drawing.
if it's
A triangle.
as a whole, does that mean it should be upright?
Yes.
Like, which way?
All right, so how does the telephone pole stand, Savannah?
Oh.
All right, so draw a straight line up and down.
Angle of inclination.
Okay.
End of the shadow.
All right, and where's the shadow at?
In front. Well, it depends
Right,
on the sun.
left, right.
I don't, well, okay, but like, that's not what I don't mean what, like, left or right. Like, where do you see shadows? On the ground, so that's the flat part.
Wait.
I don't really care what side to draw it on.
So we're drawing a shadow or
Straight
the pole?
line.
Both. You have to make the whole triangle. Okay.
Okay, so it's the 30-foot, the pole, or the
All right, here is the telephone pole. If there is, let's say the sun is over here. Let's say the sun is over here. Okay? Where would the shadow be?
Over to the right.
Yes. Shadows go on the ground. That's where we see them. Right?
Yes.
Okay, so this is the pole. This is the shadow.
But is the pole 30 foot? No, the shadow is.
It says cast a 30-foot shadow. We have to slow down and read very, very slowly. All right, now
Inclination would be.
from the end of the shadow to the top of the pole.
So that's the hypotenuse.
So from the end of the shadow to the top of the pole. Hannah? Nothing.
So that's 53 foot. So that's it.
No. It's the angle it forms.
Wait.
It says angle.
Irritated with us.
It's 53 degrees.
I already did this, so I
Yeah, you're good.
I don't. Or at least I'm trying. Can I pay you to do it for this?
No, Savannah.
Helicopter.
Just know that all of this is recorded too, guys. You're welcome.